Hey everybody, wanted to spend a little bit of time talking with you about molarity. Molarity is a way for us to calculate concentration, or how much stuff is dissolved in a solution. Okay, and so let's just briefly talk about what molarity is. And so, like I just said, it's a unit of concentration, or you could even say that it's a measure of concentration. And the unit of molarity is molar, actually. And how do we calculate molarity? Well, it's calculated by moles of solute divided by liters of solvent. So molarity is symbolized with a capital N, and moles is N, and liters is volume. So that's a capital V. So this is the formula that you'll see for this thing. Okay, so it's molarity equals N over V. Okay, and the units, because we're doing moles over liters, is either moles per liter, or it could be molar. This capital M stands for molar. So that's kind of an interesting term, and I just capitalized it there by mistake. It's not a proper unit by any stretch of the imagination, proper noun by any stretch of the imagination. And so we can use this in order to characterize solutions that we make. Before we move on, I just want to make sure that we know the terminology here. And there's two parts to a solution. There's the solvent. So in most cases, that's going to be water. Okay, water is the solvent that dissolves most of these compounds that we're dealing with. And then the solute is the thing that we put into the solvent. Now, the solvent doesn't have to be water. It is most likely going to be water, though. Okay, but the solute can be a lot of things. Okay, it could be a gas. In the example of soda, the solute is carbon dioxide. In the example of like salad dressing, and I'm not talking about oil and vinegar, I'm talking about one that's completely mixed, or even when you mix up tea and lemonade, and now you have half and half, or an Arnold Palmer. Now you have a liquid that's dissolved. Okay, and so liquid can be the solute. And then solids are also solutes: sugar, salt, other ionic compounds. So let's spend a little bit of time talking or showing you how to calculate excuse me, concentration. So this is a pretty straightforward example problem where we have where we want to calculate the molarity of this solution. It doesn't say specifically that we want to calculate the molarity. I actually took this from a different worksheet, and so it doesn't have what, calculate the molarity of each of the following solutions. But nonetheless, we can do this. So the thing to do is to set up the problem. Anytime you have a problem, I would write the formula. Molarity equals number of moles over volume. And so in this case, we already have the number of moles, 1.0. And then it's divided by the liters of solution, which is 0.1. Okay, so this is moles here and liters here. And so that math is 10 moles per liter, or you could say 10 molar. Okay, so that's a fairly straightforward problem to figure out how to just kind of the dynamics of this. But this isn't a kind of real life problem, because when you're doing chemistry, remember, when you're doing chemistry in the lab, you're going to do stuff probably in grams. Okay, you're going to probably be in grams, and then you're also probably not going to be in liters. You're probably going to be in milliliters. So let's take a look at this. Okay, so we have ammonium carbonate, and so notice here we have 952 grams of ammonium carbonate. Okay, so that's NH4 2CO3. Okay, and now to convert this, I'm going to do X line, and then I'm going to put grams on the bottom and moles on the top. So for every 1 mole, and now this is where we need our periodic table. So, nitrogen is 14.0007, hydrogen is 1.008, carbon is 12.011. Okay, so we could take that and we can use that to find the molar mass. Okay, so we have N, and there are 2 of them times 14. Okay, and I'm just going to round them. And then hydrogen is 8, because there's 2 times, so that's times, and then 1. And now for carbon, it's 1 times 12. And then for oxygen, it's 3 times 16. Okay, so now we add all of this up. So this is 48, 68, 68, and 28. So 68 plus 28 is equal to 96. So this is going to, let's see. So this is 96. Okay. To milliliters, it's 1, 2, 3. Move our decimal point. So now we get molarity equals number of moles over volume. How many moles? 9.92 divided by the volume, 1.750, and then we get an answer of 5.67 molar. And just like the last example, we could do 5.67 moles per liter. Okay, so this is what we're doing for here, calculating the concentration of solutions using moles and liters. Okay, have a great day.